Okay, so you guys have a midterm on Friday. Okay, so I'm just going to talk briefly about Friday's exam. Okay, so it will covers chapters 5, 6, and the first half of 7. Okay, and so it will not cover today's topic, which is confidence intervals. Okay. It does not cover confidence intervals, and let's see. I would say review quiz 2 and 3. Have you guys gotten quiz 3 back yet? No? Okay. So then, okay. So you might, if I haven't done this by 5 p.m., send me a reminder. I will, I have like a practice quiz 3 that I'll post with some with answers as well. Okay, so I'll post a practice quiz 3 that you can start to study. Okay. Okay, and let's see what else. Review your notes. Something is. Sorry, I'm struggling here. Okay, so review lecture notes. Review lecture notes for chapter 7. Okay, and so make sure you can do a sampling distribution problem. I apologize, I'm struggling with my pen here. Sampling distribution problems. Checking the conditions for using the central limit theorem. Okay, and then there's a handful of other conceptual questions. I would say this one has a versus midterm 1. This one has a stronger emphasis on calculations, but there's still going to be some conceptual questions. Okay, but I'd say more calculations than conceptual. Okay. Midterm 1, I would say the conceptual questions were a little bit more heavily weighted. Okay. All right. Is that okay? Any questions there? Yes. So it'll be all multiple choice, and be sure to bring your tables. Be sure to bring your tables and bring your calculator. Okay, so I mean your table just being the Z table. Okay. All right, then if that's okay, then then we'll move on here. Okay, so here now we're going to start talking about confidence intervals. Okay. And the idea behind confidence interval is this is kind of our first step into statistical inference. Okay, so this is kind of our first statistical inference tool. Okay, so it's like, so what is the point of statistical inference? So I kind of mentioned this at the very beginning of the course, and I said in statistical inference, the big picture idea is that we are trying to make conclusions from limited data, right? So the idea behind statistical inference is that by just observing a sample of data, can we then make conclusions about the population? All right. So that's what we're going to do. Okay. So by observing just a sample of data, can I then make conclusions about the population? Okay. Again, because in our general diagram, the population represents a large entity that is too big to be observed directly. Okay, and so because we can't survey every single person in the population, we take a random sample that we can observe. Okay, so the idea here is, you know, a lot of times you'll see opinion polls being published in the news. It'll say, you know, a certain person has, you know, this approval rating, and maybe it's whatever, you know, and they say stuff like this, right? You know, nobody called me and asked for my opinion, but and chances are nobody, maybe some of you were asked your opinion, but by and large, probably most of you were not. And so the idea is, you know, they're publishing these results based on the results of a sample, okay? And so basically the idea is, you know, let's say we're talking about a categorical variable. You know, maybe our question is, you know, we want to know what is the proportion of people in the population okay, who say, you know, yes to the question. So the question could be, you know, do you approve of so-and-so? Okay? Some people say yes, some people say no, okay? And so maybe the true value in the population, whatever value that is, okay, that value is the parameter, and that's going to be P. That value is the parameter, okay, and in this case it's the population proportion P. Okay, and over here we have our sample, okay, and the proportion we observe in our sample is the statistic. And this is called the sample proportion p hat. Where p hat is equal to x divided by n. X will be number of yeses, and n is our sample size. Okay. And so let me kind of illustrate, with a little bit of a. So if you remember, do you guys remember the Reese's Pieces example for sampling distributions? When I introduced the concept of sampling distributions, I said we know that the population of Reese's Pieces is 30% orange or something like that. Okay, I said I know that it's 30% orange, and because I know that, what does the distribution of p hat look like? Okay, this time let's say we've dumped out a new thing of candies. Okay, and now this time we don't know the actual proportion that's in the population. Okay, so maybe we want to know what's the proportion that's yellow in the bucket. Okay, this time I don't know the actual proportion that is yellow. And so the question is, if I take just a scoop of candies and I look at my scoop of candies, does this tell me something about the proportion that is yellow? So here I can have a bucket of candy. We'll say Reese's Pieces. Okay, and I'll say I do not know the proportion of yellow candies. I do not know the proportion of yellow candies. Okay, so if I'm going to draw a scoop. Okay, so I take a scoop, let's say of 150 pieces of candy, and let's say 54 are yellow. Okay, what does this tell me about the proportion that is yellow in the bucket? So, what I can do is I can say, well, my p hat is 54 divided by 150, which is, I don't know, I need a calculator here. 54 divided by 150, what is this? This is 0.36, okay. Okay, so my scoop of candies is 36% yellow. What does this tell me about the proportion that's yellow in the entire bucket? Okay. Does it tell me anything? Like, what can I start saying about the proportion that's yellow in the bucket? Okay, I can't say. Can I say that the proportion of yellow pieces in the bucket is 36%? No, we can't say that, right? Can I say that the proportion of yellow pieces in the bucket is not 90% yellow? So, if somebody else were to draw a bucket or a scoop of yellow candies, and they said, oh, I only got 30% yellow, would that be surprising to you? Probably not. I mean, maybe you'd be like, oh, okay, well, I got 36. But 30% yellow, that probably wouldn't be shocking, or 30, somebody got 34% yellow or something. That probably would not be a surprising value. If someone says, I got a scoop of candies and it was 90% yellow, you'd say, that doesn't sound right. Did you use the same bucket, or did you not mix it up? We would get the sense that something is a little strange here. Okay, well anyway, so the idea here is, based on what we observe, if we observe just a p hat, what can we say about p? Okay, that's the premise behind confidence intervals. All right, put that thought on hold. Okay, so far we've said, we're not exactly sure what we can say about p, but 90% would be surprising. Okay, so again, the idea is we've observed a p hat and we want to know what can we say about p. All right, so keep that in mind, and now I'm going to tell, I don't know, do an illustration here. All right, let's just go. Okay, all right, so let's say, all right, so someone posts this, someone shares this picture on Snapchat here, and let's say it's a beautiful picture. What is this? All right, so this is a picture of a dog. Okay, there we go. All right, and it's lovely, right? Okay, and it's a picture of a dog. And we'll say he's on the football field. All right, okay. And he's on the we'll put him at the 30-yard line there. Okay. And it says a good boy. All right. Okay. All right. So and then the question, but then there's a few other things that say okay, but now we say you learn later. Where is the owner? Okay, and you're like, what owner are you talking about? And then it says, aha, the owner is invisible. This is getting weirder by the second. Okay. And the dog is going for a walk, and the leash is invisible too. Okay. Okay, and so we're asking, where is the owner? All right. So basically, we see the location of the dog. We want to know, where is the owner located? Okay. Well, there are a few things. We understand some behavior of the dog. So we understand a bit about the dog's behavior. Okay, and what we understand is that that the leash is elastic. It's an invisible elastic, and the dog doesn't like to pull too hard against the leash. Okay, so the general idea is the dog does not like to pull too hard against the leash. Okay, but the leash is elastic and can stretch. It's really high quality invisible elastic, and can stretch really far. And somebody did a study on the dog's behavior earlier, and we can benefit from this. And we'll say, in fact, we've learned that 68% of the time, the dog remains within 1 yard of the owner. Okay, and then in 95% of the time, the dog is within 2 yards of the owner, or meters if you like metric. And then, 99.7% of the time, 3 yards of owner. Okay, so if I see the dog at the 30-yard line, and I know he's going for a walk with his invisible owner and invisible leash, what can we say about the location of the owner? Can we say anything about the location of the owner? Okay, what can we say? So I can make a statement, something like, I am 95% confident that the owner is between 28 and 32. Does that make sense? Okay, because we know the dog remains within 2 yards of the owner 95% of the time, if I see the dog at the 30, I can be 95% confident that the owner is between 28 and 32. Okay? Or I can say, I am 99.7% confident that the owner is between 27 and 33, right? So basically I'm doing this over here is 28 plus or minus 2. 28 plus or minus 2, and this is, sorry, not 28, this is 30 plus or minus 2, and then down here is 30 plus or minus 3. Okay, does that make sense to everybody? Now, is it possible that the owner is at 33.5? Is that possible? Yeah, that's possible. Okay, I mean, it's an elastic leash. The dog could be straining really hard, right? So it is possible for the owner to be at 33.5. However, this would be surprising to us because that means the picture was taken at one of those very rare occasions where the dog decided to go more than 3 yards away from the owner. Okay? Okay, so why did I bother with all of this dog and elastic leash nonsense? The idea is when we are dealing with our confidence interval, okay, the dog represents p hat, okay? The dog, this is the quantity we get to observe from the sample. We get to see our sample proportion p hat, okay? Whereas the owner is the location of the population proportion p. This is the value that we are interested in. We want to know what proportion in the population is the thing, okay? And the behavior that we understand about the dog, all of this is the central limit theorem describing the sampling distribution, okay? What we learned when we talked about the central limit theorem and the sampling distribution is that the behavior of p hat follows a normal distribution, okay? And because we know p hat follows a normal distribution, we know that 68% of the time it's within 1 standard deviation of the mean, okay? 95% of the time it's within 2 standard deviations of the mean, and 99.7% of the time it's within 3 standard deviations of the mean, okay? And so therefore, we can say something along the lines of, I am 95% confident that P is between 28 and 32. It would be P is between, P hat plus or minus 2 standard deviations, okay? And that's where we are headed when we actually formulate the confidence interval, all right? Does this kind of make sense, what we're doing here? So we want to know about P, which is unknown to us. It's like the invisible owner, okay? What we get to see is P hat, okay? From the central limit theorem, from what we learned about sampling distributions, we learned that P hat follows a normal distribution, which means most of the time P hat is close to P. Okay, so let's put this all together. Okay, so from what we know about sampling distributions, okay, we know that P hat comes from a normal distribution centered at P, okay? And that all that's to say is that P hat, is usually close to P. Okay? And so therefore, we can say something along the lines of I am 95% confident that P is between P hat minus 2 standard deviations and P hat plus 2 standard deviations, okay? And when we actually look at the normal distribution table, we find that there's a better value to use than 2, okay? So a better value to use is 1.96, okay? So that's what I'm going to say. Don't use 2, use 1.96, okay? So don't use 2, use 1.96. Okay, because if you look at the normal distribution, if you want 0.95 in the middle, and you want 0.025 out here and 0.025 out here, negative 1.96 and positive 1.96 are the values you want. If you go to 2, you're going to get a little bit less, like 0.0224 or something, okay? So anyway, we're going to go P hat minus 1.96 standard deviations and P hat plus 1.96 standard deviations. Okay, what's the size of our standard deviation? Do you remember? So for sampling distributions, it was the square root of P times 1 minus P divided by N. Is that okay, right? You remember? Okay, so so we're saying, I am 95% confident that P is between, we'll just say P hat plus or minus 1.96 standard deviations. Okay, so for sampling distributions, the standard deviation is the square root of p times 1 minus p divided by n. Okay, does that look familiar? It should. You'll need to know it for Friday. Okay. So the standard deviation is this. Okay. There's one problem here, and that is we don't know what p is, right? The whole point of making the confidence interval is we're trying to figure out what p is, and we don't know what that is. So for a confidence interval, okay, we do not know what p is. Okay, so we will substitute p hat. Okay, so our standard deviation here, okay, and we're going to call it our standard error. So our standard deviation, which we'll call our standard error SE, is the square root of p hat times 1 minus p hat divided by n. Okay. And is it okay to plug in p hat instead of p? Well, I'm not going to bother trying to prove this, but mathematically, it is okay to do this. All right, it's it is okay to use p hat instead of p. Later on, we'll do confidence intervals for means, and we're going to plug in S as an estimate for sigma, and that messes things up mathematically a little bit, so we have to make adjustments. All right. So far, so good? Okay, so we'll put this all together. All right, and I'll say make a 95% confidence interval for the proportion p, which is the proportion of yellow candies in the bucket. Okay, and what we have is, our data is the sample. We have a sample of 150 candies. And what did I say? 54 of them are yellow. Okay, so this is our sample. It's a random, random sample of 150 candies. 54 of them are yellow. So based on this, make yourself your confidence interval. Again, we have p hat plus or minus. We're going to do 1.96 times our standard error of p hat times 1 minus p hat over n. Okay, so I'll just ask, what is the upper bound? Okay, the upper bound is, because our confidence interval is p hat plus or minus what we call the margin of error. It's either up 2 or down 2 or up whatever it is. The upper bound is just the side where you do the addition. Okay. All right, I got to make some. We'll make some fake answers here, and we'll turn it into a clicker question. So here is your okay, so here's your clicker question. Okay, go ahead and see what you can get. Again, the question is, what is the upper bound? So, basically you have p hat minus 1.96 times. This is going to be the lower bound to the upper. Okay, let's take a look at how we did. Okay, and that is correct. So what we do, so we have x is 54, n is 150, and so therefore my p hat 54 over 150, which is 0.36. Okay, and so now my upper bound is going to be 0.36 plus 1.96 times the square root of 0.36 times 1 minus 0.36 divided by 150. Okay, and that should give you 0.437. If you got this, you forgot to multiply by 1.96. Okay, and then 0.039, that's your standard error. Yes, question?
Could you explain why you multiply by 1.96?
So the reason why we're doing 1.96, it's kind of here. Let me explain here. Is if we look at the normal distribution, okay, and I said, what are the boundaries if I want to capture the middle 95%? If I want to get 95% in here in the middle, okay, how much would I then have in each tail? I would have 2.5%, right? I would have 2.5% up here, 2.5% down here. That gives me a total of 5% outside of the range, and that will add everything up to 100%. Okay, and so if we look for, what is the z that gives me 2.5%? That z is negative 1.96, and this z over here is positive 1.96. So that's why we have 1.96 for a 95% confidence interval. Okay. If we wanted to have a higher level of confidence, okay, so this is for a 95% confidence interval, this is what we have. For a higher level of confidence, we can simply make our range wider, okay? For a higher level of confidence, okay, and so in that case, if we want to be 99% confident, okay, then I only want 1/2 of 1% over here and 1/2 of 1% over here, and I'll have 99% in the middle, and this will give me negative 2.58, and over here will give me positive 2.58. Okay, so the value, what we call the critical value we use for a 99% confidence interval is 2.58. Okay. Now you might say, well, what if you want to be 100% confident? Okay. Well, the only way you could be 100% confident about any proportion is to go from 0 to 1. Okay. I can say, whatever it is you're talking about, what proportion of people like, some new thing or whatever. Well, I'm 100% confident the answer is going to be between 0 and 100%. Okay. But that's not a very useful answer, right? Nobody wants to hear that. They just think you're being trying to be funny or something. but that's the only way we can be 100% confident about any kind of proportion. Okay, so you have to, as soon as you don't include every single possible value, you can no longer be 100% confident in your answer. You can be very, very confident, like close to 100%. Okay, but there's this trade-off between how confident you want to be and how wide or narrow your interval is. In general, people rather have precise estimates. We'd rather have a narrow interval, right? If you're gonna do some budget planning for next year, okay, maybe you guys don't do any budget planning right now, but if you're gonna do some, it would be helpful to know how much money you're gonna make next year, okay? And if someone says, well, I'm pretty sure I'm gonna make between $0 and $1 million next year, it's hard to do any kind of budget planning there, all right? But if you can say, well, I'm pretty sure I'm gonna make between $900 and $1,100 every month, then you can start budgeting things out, and just to be on the safe side, you probably budget less, and then you might have a surplus or something. And so a more narrow interval is useful, but the more narrow you make your interval, the less confident you can be about that estimate here. Okay, we'll continue this topic the following week on Monday. Good luck as you guys study, and I'll see you guys on Friday for the midterm exam.